Math 2, Unit 7.1. Today we're talking about the Pythagorean theorem. You should be on page 415. One thing that you need to remember about the Pythagorean theorem, besides the formula, and I think most of you probably have that formula memorized, a squared plus b squared equals c squared. In order to use the Pythagorean theorem, it has to be a right triangle. Also, the two legs can be interchanged, but your hypotenuse is always the hypotenuse. And we know that the hypotenuse is always your longest side, or the side across from your 90-degree angle. Is everybody good with that? Yes? Okay. Moving on. Page 416. Oh, I have the wrong one. Sorry.
This is all your
All right, page 416. Okay, so there's something called a Pythagorean triple. Okay? And a Pythagorean triple is a set of non-zero whole numbers that satisfy the equation a squared plus b squared equals c squared. Okay? So right here they have some common Pythagorean triples. A lot of you might remember a 3, 4, 5. Which number would be your c? 5. So your c value is always your largest number. Okay? And then we have 5, 12, 13, 8, 15, 17, 7, 24, 25. Okay. If you have these triples, if you were to multiply, like let's say if you multiplied this one by 2, what numbers do you end up if I multiply each of those by 2? We get 6, 8, 10. Okay? That is also a Pythagorean triple. So each of these sets, you could multiply them by any number, as long as you multiplied every single number by the same number, and that would give you a new Pythagorean triple. That would work. Okay. So if I were to draw a triangle here, if we're going to go to problem 1, got it. The legs of a right triangle have lengths of 10 and 24. Okay, so when they're talking about the legs, they're not talking about the hypotenuse. So that means this is 10, this is 24. And it says, what is the length of the hypotenuse? So you could give that x, you could give it c, whatever you want to do. So our formula, a squared plus b squared equals c squared, would be 10 squared plus 24 squared equals x squared or c squared. You might want to use a calculator for some of this. 10 squared though is 100, 24 squared is 576 equals x squared. We add those together, we get 676 equals x squared. Now, if you can get a whole number, you can use your calculator. And so in order to find what x equals, we take the square root of both sides. And so in your calculator, you have to get the square root symbol in there. And if I type in 676, I get the answer of 26. So x equals 26. So if I were to write, this means that this is a Pythagorean triple. So that's 10, 24, 26. On part B, it says do the side lengths in part A form a Pythagorean triple. Well, there's a couple of things. So the answer is yes, okay, because all of them work. But a specific triple, is there a way of taking these? Could I do something and get back to one of these triples up here? Yeah. So 5, 12, and 13, if you take that and multiply it by 2, it makes the 10, 24, 26. Okay. Do we have any questions? So your answer is yes, and your answer is 26. And then we were just talking about how it's a Pythagorean triple. Okay. You don't have to necessarily write this in words if you just kind of show. Okay. All right, so we are moving on to the practice problem number 1 there at the bottom. And you need to find the value of x. So I'm going to give you a minute to try that one on your own. Okay, once you get your answers, check in your group, see if you guys agree. Oh, it feels good. Okay, so when you set this one up, you should have had 8 squared plus 15 squared equals x squared. 8 squared is what? Good. Plus 15 squared is equals x squared. We add those together, you get 289 equals x squared. When you take the square root of both sides, you should have got what? Good, 17. So 17 is my answer. Now, number 2 says, do the numbers 4, 5, and 6 form a Pythagorean triple. Does anyone have any idea on how we can figure that out? How? Good. 4 squared plus 5 squared equals 6 squared. That's exactly it. If you plug those numbers into your Pythagorean theorem, you want to see if they end up equaling each other. If they do, it's a Pythagorean triple. If it doesn't, then it is not a Pythagorean triple. And we always know that our C value will be the largest number. Okay, so we get 16 plus 25 equals 36. What is 16 plus 25? Does 41 equal 36? No. So therefore the answer is no, it is not a Pythagorean triple. Okay, questions? All right. I want you guys to turn to page 418. Okay, so we have a word problem here. It says the size of a computer monitor is the length of its diagonal. You want to buy a 19-inch monitor that has a height of 11 inches. What is the width of the monitor? Round to the nearest tenth of an inch. Okay, so we have our computer monitor. We have the diagonal. Everybody okay with this picture so far? Okay, so the numbers. It says you want to buy a 19-inch monitor that has a height of 11 inches. Where does the 19 go? Good, your C value, or the diagonal. And the 11 is your height. And then we need to find our width. So I'm just going to put an X there. So how will I end up setting this one up? Okay, 11 squared plus x squared equals 19 squared. Good. What is 11 squared? 121 plus x squared equals, and then 19 squared is what? Good, 361. In order to solve, we have to subtract 121 from both sides. X squared equals what? 240. We take the square root of both sides. And it says round to the nearest tenth of an inch. So that means that on your calculator, we'll do the square root of 240. And the tenths place is the one to the first one to the right of the decimal. So am I going to write 15.4? Good, it's going to be 15.5. Why? Good. So if I'm rounding to the 10th place, we look to the number in the 100th place, and if that one's 5 or bigger, we round up. If it's less than 5, then we just drop the rest off. Okay. Now, we were following instructions and we got the decimal. One thing is that most of the answers on your test do not have decimal answers. They leave it in root form. Do you guys remember how to simplify square roots? So I want to show you another way of looking at the square root of 240. If it doesn't become an exact number, you need to break this down. Do you guys remember how to do like your factor trees? And how many do you need to make a pair? Or I just told you the answer. 2. You need 2 to make a group that gets pulled out of the root. So let's kind of work through this one. So what 2 numbers multiply to be 240? Let's go 24 and 10. Is that okay? Okay, and then you have 24 and 10. What does 24 break down to? 6 and 4. And then 10 is? Okay. And then 6 is 3 and 2. 4 is 2 and 2. And then I still have 2 and 5. So do you see I have a group of 2's and another group of 2's? Okay, so anything that has a group, when it gets brought out, it's just one of those numbers. Whatever doesn't have a pair or a group, those stay inside. I usually always box those so I don't forget to multiply them. But this would end up, does anyone know what this ends up becoming? So I have 2 2's that get brought out. So this group becomes 1 2, and this group becomes 1 2. So I have 2 times 2 on the outside of the root. And then on the inside of the root, it's 3 and 5. What is 2 times 2? Root 15. So 4 root 15 is the same answer as 15.5. So each of the groups just become 1 2. So this group became a 2, this group became a 2, and anything that wasn't in a group stayed under the root. Okay? Say that one more time. You can break down the numbers differently. Like, I could have ended up with a 4 and a 4. And then I could have just grouped the 4's instead of breaking them down to 2 groups of 2's. Okay? All right, let's go into number 5. We'll get some more practice with this. Okay, so a painter leans a 15-foot ladder against a house. So normally what I like to do is draw a picture. So I have a house, and then I have a ladder over here being leaned up against the house. Pretty good? Pretty nice picture. You can tell I took art in college. Okay? Yeah, I really did. Okay, but anyways. I know it's not good. Obviously, I didn't do great in that class either. Okay, so it says it's a 15-foot ladder. So where does that 15 go? Yeah, on this C part, right? This is my ladder that's being leaned up against the house. That is my 15. Okay, so think about how your pictures are. It says the base of the ladder is 5 feet from the house. So this is the base is the bottom, right? So it's saying from here to the house is 5 feet. So I have to write a 5 there. And then it says to the nearest tenth of a foot, how high on the house does the ladder reach? So that means we're trying to find that height, that X. How will I set that up? Christian. Good. And again, you can use whatever letter you want to there. So 5 squared is 25 plus x squared equals 15 squared is good. We subtract 25 to both sides. X squared equals We take the square root of both sides. And when you put in your calculator, what did it equal? Okay, so square root of 200, 14 point what? 1. Okay, but we are also going to practice breaking that down. So, square root of 200. What two numbers multiply to be 200? Okay, 2 and 100. Okay, what does 100 multiply? What two numbers multiply to be 100? Okay, I would choose 10 and 10. Why would I choose 10 and 10? It reduces the amount of work you have to do because now I have a pair of 10s and I can stop there. Once you have a pair of numbers, you don't have to break them down further. So I have a pair of 10s and a 2 left over, and so I end up with 10 root 2. So again, remember the pair becomes just one number, so 110 that gets brought out, and then the 2 left over inside. Are we okay with that? Yes. So any pair that you have goes to the outside of the root. And so if we had multiple numbers that you brought out, you multiply the numbers outside together. So that's like on here, I had one group of 2s and another group of 2s, so I wrote that as 2 and 2. Okay? Any number that doesn't have a group, it didn't have a pair, it stays under the root. And you end up multiplying those together. So on this one, it just happened that there was one group. Once you have a pair of numbers, you can stop, and that group gets brought out, and then that 2 had to stay inside. Also, I was going to show you that you could double check that you simplified this correctly. And if I write 10 and then the square root of 2 and press enter, do you see how it still gives you the 14.1? So that's a way of double checking that you simplified it correctly. Okay, number 6. You're still on page 418. So it says a walkway forms one diagonal of a square playground. So a square playground means that all of the sides are the same. And then you have a walkway through it. It says a diagonal walkway through the playground. It tells you the walkway is what? 24. So this is 24. To the nearest meter, how long is a side of the playground? Okay, now, they only gave us one number. Normally, we need to have at least 2 numbers to solve this, right? But we know that both sides are going to be what? The same or equal. So I can give both of them the value of x. So if we were to write this out using our Pythagorean theorem, how do I write it? Good. So x squared plus x squared equals 24 squared. Because this is still my c, right? Across from our 90-degree angle. And then each of the sides are x. Now, what's x squared plus x squared? Good. 2x squared equals, and what's 24 squared? Good. Okay, and then what would I do to solve this? Divide by 2. We have x squared equals, and 576 divided by 2 is good. And then we can take the square root of both sides, and we get that x equals, plug it into your calculators, what do you get? I think I hit 17. Are we having a hard time? Yeah, because we would round it up, right? And so that 9 would end up changing to a 10, which makes it 17. Okay? So x equals 17 meters. Okay? Should we go ahead and practice breaking this one down? Yes, that sounds like a great idea. Okay, so 288. What two numbers multiply to be 288? Yeah, if you're ever not sure, 144 and 2. What about 144? Very good. 12 and 12 is a good choice because then I have a pair and a 2 left over. And how would I write that? Good. 12 root 2. Okay, moving on. Okay, now you're looking at page 419. So basically they're just telling you the converse, and that is if you know that a squared plus b squared equals c squared, then it has to be a right triangle. Okay, so when we have a right triangle, we know a squared plus b squared equals c squared works. Vice versa, if this works, you know it's a right triangle. Okay. So we are still on page 419. And it says a triangle has a side length 16, 48, and 50. Is the triangle a right triangle? What are you going to do? What will we do to check if it's a right triangle?
16 squared plus 48 squared equals 50.
Good. If they end up equaling each other, it's a right triangle. So 16 squared is 256. 48 squared is
2,300.
very good. And 50 squared is perfect. If you add these two numbers together, 256 plus 2,304, what does that equal? What is it? And does that equal 2,500? No. So, is it a right triangle? No. Okay, B. Once you know which length represents the hypotenuse, does it matter which length you substitute for A and which you substitute for B? No. Why does it not matter? Everything that you basically said is correct, but basically it's that A and B are adding, and whenever you're adding two numbers, it doesn't matter your order. If you're subtracting, does order matter? Yes. Okay, any questions here? Okay, we are moving on now to page 420. Okay, so number 7, I'm going to give you about a minute or less. Is it a right triangle? So you can show me on your fingers once you get the answer. 1 is yes, 2 is no. Good, 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 good. 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 1 is yes, 2 is no. Good. 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 Perfect. Got it. Got it. Okay, so 20 squared plus 19 squared equals 28 squared. You should have had 400 plus 361 equals 784. When you add those, 761 does not equal 784, so that means no, it is not a right triangle. Okay. Moving on, still on page 420. Okay. So, now just because they don't make right triangles doesn't mean they aren't triangles. So there are obtuse triangles, acute triangles, and right triangles. Okay. If c squared is bigger than the other side of the equation, that means it is obtuse. Okay? If c squared is smaller than the other side of the equation, that means it is acute. Okay? And then if c squared is equal, then that means it is a right triangle. Okay? Are we all okay with remembering obtuse and acute? Obtuse and acute? Okay, obtuse, it always reminds me of like big, obese, obtuse. Okay? Acute, small things are cute, right? So therefore, small is acute. Okay. Moving on. Okay. To got it, page 421. Okay, so 789, is it acute, obtuse, or right? So we set up the same equation. Okay? So this is my C, right? So if I write this as 9 squared, you can think of it this way, blank, and then 7 squared plus 8 squared. So 81, and then 7 squared is 49, 8 squared is 64. When you add those together, what is 49 plus 64? So since my c squared is smaller, okay, so I'm going to write here, c squared is smaller than the other side, that means it's what? Acute. Okay, so on number 9, this is my C. We have 0.6 squared, and we're checking to see what happens when we take 0.3 squared plus 0.4 squared. 0.6 squared is 0.36. 0.3 squared is 0.09. 0.4 squared is 0.16. When you add those together, you get 0.25. C squared is bigger, right? Which means it will be what? Obtuse. Okay, number 10. This is your C again. Now, so that means when I write this, I have 4 squared, and then I have root 11 squared plus root 7 squared. What happens when you square a square root? Basically, the root goes away and it just becomes that number. So that means I get 11 plus 7. And 4 squared is 16. 11 plus 7 is 18. 16 is less than 18, so that means acute. Okay, do we have any questions? Yes.
Square root, square, Pascal is regular.
Yes. So anytime you square a square root, it just becomes whatever was under the root. Any other questions?